Controlled hierarchical summarization for long-form spoken dialogue. Every day we are surrounded by various forms of spoken dialogue: interviews, debates, meetings, and conversations with friends and mentors. These are all rich sources of information. However, accessing this information is difficult because these sources invariably contain the shared challenge of interpreting an auditorily rich stream of information. Now imagine receiving an email from a colleague about an exciting interview on YouTube. It's 23 minutes long, you're not sure if you want to commit to watching the whole thing, but you want to know if there's anything new or interesting in it. The goal of this system is to help people explore audio and find key takeaways quickly. Automatically summarizing and distilling content to the most interesting points would be an ideal solution. We can create such a system by combining a speech-to-text model with a text summarization model. By processing audio into transcripts, inserting punctuation, and deploying a text summarization model, we should theoretically be able to output condensed text representations of a long audio file. However, simply using pre-existing solutions is not sufficient and has practical usage concerns. Automatic speech recognition has word recognition errors that can mislead users. In this example, whether, as in whether or not, should be a seasonal weather. Predicted punctuation errors can split off sentences, creating incomplete context. In this example, the sentence is split into two, creating new meaning. Unfortunately, speech training data is not easily obtainable. Summarization models are trained on clean, structured text and are not well suited towards speech, which contains its own set of challenges, such as disfluencies and lack of structure. This leads to hallucinations or incorrectly outputting unseen words. Speech may also be ambiguous, confusing summarization output. Ultimately, these errors prevent practical usage. Still, we explore these models for feasibility in a novel speech summarization system. Investigating the exact errors, we discover that some language models may be reused. We find that models trained on typical data, such as news, are not suitable. However, models trained on paraphrasing noisy text show promising results, but still do not reach a usability standard. Due to the nature of summarization, a model must understand the underlying semantic content. Otherwise, the output will be illogical. Our paraphrasing model still suffers from this. However, semantically grouping the input into chunks helps model comprehension. By presenting the input text as discrete and unique topics, the model does not need to reason between multiple ideas. Nonetheless, machine learning systems are imperfect and impose additional design considerations. In our system, we consider the following: user intent, as users have different goals in understanding information content; user navigation, to support different browsing habits; and user error correction, to recover comprehension due to incorrect AI-generated summaries. The system presents summarization in a hierarchical manner. Starting from the ASR segments, we recursively combine similar summaries to obtain increasingly abstract ones, providing users varied levels of detail. Here we see how the information is presented. Clicking on the short summary gives a high-level idea of this audio segment, and each subsequent level provides increasing detail, allowing the user to read as deep as they want. Lastly, the user has the option to read the speech-to-text transcript and listen to the original audio segments. Our system supports two forms of navigation. By presenting short summaries start to finish in a linear fashion, users can read short summaries to get an idea of the speaker's conversational flow. Alternatively, users can use short summaries as indexing tools to select segments they are interested in. Our system also affords user error recovery from machine learning errors. Using tiered information, users can understand that the partner experiences referenced in the short summaries are within the context of a retail Starbucks store. In this example, we see how the ASR segment outputs.
We're in the midst of what's probably one of the largest reckonings around racial equity.
By listening to the audio, we can conclude that the rectangle openings should be the word reckoning. For our experiments, we evaluated our system on 10 participants. Users individually scored 556 summaries, and we found that 71% were immediately understandable and 98% were understandable upon further investigation. Out of all users, we find they spend 27% of the time they would have spent compared to listening to the full audio file. Lastly, we go over qualitative user feedback. You can scan a 20-minute interview in a minute and find the parts you find interesting. I would get this as a YouTube plugin. I found that I could use the short summaries as subheadings and individual bullet points. It structures information well by length and complexity. Automatic Spark Notes for boring talks. So in conclusion, our system affords accessibility, user intent, user control, and error recovery. Thank you for listening.